I'm going to go over lesson 61 and 62 with you. Try to get through these as quickly as I can. To start with, lesson 61, talking about subsets of sets. We discussed sets a couple of lessons ago, and we're going to talk about subsets. And you can see the two symbols I have up here. This kind of more of a sideways looking U represents subset. And let me get my pen going. Didn't want to take off yet. Get everything lined up here. All right. So this means subset. If you put a slash through something, it means it's not a subset. And a subset is simply a smaller set from a given set. Your Algebra 1 class is a subset of the 8th grade class. Your Algebra 1 class here is also a subset of the middle school. You're a smaller group of a bigger part there. That's what subset means. We're going to read this. A subset of a set is a set of numbers where all the members in one set are found in another. Okay? And here we go. I used 8th grade. 8th grade boys are a subset of the 8th grade, and I didn't type an S on boy there, but it's supposed to be. 8th grade girls are a subset of the 8th grade because all the 8th grade girls are in the 8th grade. And then the question I have is the 8th grade Algebra 1 class a subset of the 8th grade? I already gave that one to you, didn't I? Yes, it is, because all of you are 8th graders. All right, let's go on. Okay, here's your two sets. Set A has the elements or the parts 1, 3. B has the parts 1, 2, and 3. So is A a subset of B? Are all the members in A found in B? 1 and 3 are in A. 1 and 3 are found in B, so that is yes. A is a subset of B. Now, can we turn that around? Is B a subset of A? And I'm just reading left to right on this. That term or that symbol there just means subset. So we're just reading it in order. It doesn't matter which direction it's facing. So is B a subset of A? Are all the parts here in B found in A? Well, no. 2 is not in A, so B is not a subset of A. I guess my answer is no, not. So the answer is no. Okay, you're given the sets D, E, and G. Tell which of the following assertions are true and which are false. So on A, E is a subset of G. Are all the elements in E found in G? So are all of these in that? Well, that's obviously no, because E goes to infinity. And G only has 3 elements, so that is a false statement. Are all the elements in G found in E? Well, let's look. We have a 1, there's a 1. 3, there's a 3, and there would be a 5 as well. So that is true. G is a subset of E. Is D a subset of E? No, because D has 0 in it, E does not. So D is not a subset because that one member is not there. Okay. I am not going to draw this out with you. You should have, from test prep, the diagram in your notes of the real number system. Remember we had, we had irrational, and I'm going to abbreviate this really quick. I'll do this much. The irrationals rationals, and you can again look in your notes for the more specific information. Integers, whole numbers, and I'm short one here. No, I'm not. Whole numbers, and then we had natural or counting. Look that up. You can hopefully remember that irrational or square roots of numbers that don't work out, rationals are fractions, and then go from there. So with that information, is 1/2, or 1/2 is an element. Now that E represents element. 1/2 is a subset of what real numbers? Wait a second. What set of the real numbers is a subset of? Sorry. So it's a fraction, so it'd have to be a rational. It's a fraction, so we don't have fractions in the integers, and the whole numbers are counting numbers. But it is, and I didn't show this on the previous slide, but this, remember, represents the real numbers. I mean, it's titled that, but this is the set of real numbers, and so the fraction is a member of that as well. So rationals and reals. Five is an element of what subset of the real number system? Well, can we write it as a fraction? Yes, so it's a rational. Oops, I need to start off. Every number is a real number, so we should always start off with the real numbers. Rational? Yes. Is it an integer? Yes. Is it a whole number? Yes. Is it a counting number? Do we use it to count with? Yes. So counting or naturals, depending on what you have. I really feel like you guys should be able to do this without much effort. You just look back. What subset is this number? Well, it's still a real number because it's a number. We cannot take the square root of 2 evenly, so that makes it an irrational number. Okay. And that's it. Tell whether the following statements are true and false, and then explain. Are the real numbers a subset of the integers? The real numbers are everything. The integers are a smaller part. So are all of the real numbers going to be inside the integers? No. That is false. Okay. Here on B. Are the irrational numbers a subset of the reals? Are the irrationals a smaller part of the reals? Yes. So that is a true statement. The irrationals are a subset of the reals. That's true. Okay. The irrationals a subset of the rationals? No, they're on polar opposites. So that's a false statement. Neither one of those are inside of the other, so it can't be a subset. Are the wholes a subset of the naturals? Do the naturals have 0? No. So this is false because naturals do not have 0. Now, if we turn that around, would the naturals be a subset of the whole numbers? Yes, because all the natural numbers are in the whole numbers. The whole numbers have the extra part of 0, but all the naturals would be found in the whole numbers. And then our integers a subset of the reals? That is true, because everything is a real number. Okay, so that's lesson 61 that you did yesterday. Now lesson 62. You will need a calculator to do some of this. So get out your calculator. If you do not have one, I would rather you watch this than to get up and go get one. You can use one later, just watch for now. All right, so the first part of this isn't a big deal. Use your calculator to determine to 5 decimal places the square root of 18. So whenever I type or take the square root of 18 on my calculator, it may take a second to get it up here. If I take the square root of 18, it shows me that that's 4.2426406. And I'm asked to round that to 5 decimal places. I'm going to go 1, 2, 3, 4, 5. So that's the 4 is in that spot. Point at the 0. 0 is going to keep it at 4. So my answer would be 4.24264. Just rounding it to whatever decimal place it is. Now this next one has something new for you. What are the 2 square roots of 25? I'll let you think about that for a second. What are the 2 square roots of 25? What number can I take times itself twice to give me 25? I think most of you would get the number 5. 5 times 5 is 25. But the second one is negative 5. If you take negative 5 times negative 5, that's a bad guy leaving town. That's a good thing. 2 negatives make a positive. So the 2 square roots of 25, and we can show it this way, is a little more common, as plus or minus 5. Meaning positive or negative 5 would be the 2 answers there. So we have this extra idea now. When we're taking the square root of a number, what are the 2 possibilities that it could actually be? I know that's new. We've always talked about the square root of a number being the one number that could be times itself. But technically, could be more than one. Here, use a calculator to determine the 2 square roots of 10 to 6 decimal places. 10 to 6 decimal places. So type in the number 10 in your calculator. Yep. 10 square root. I get, I can see it mine, 3.1622776. Now 6 decimals, that would be, let's use a different color here. 1, 2, 3, 4, 5, 6. I barely have enough places on my calculator. Your calculators may not. If you don't, you might want to see if somebody will let you borrow theirs. So I have circling 7, pointing at 6. 6 is going to round 7 up to 8. So your answer then is 3162278. 3.1622278. That part shouldn't be a big deal. Here, without using a calculator, determine the following. The cubed root of 8 is 2. Can that be negative 2 is my question for you. Let's look. Negative 2 times negative 2 times negative 2 would give you a negative 8. So that is the only solution for that one is 2. The 4th root of 81. Just to jump to it, that's 3. But how about negative 3 on this one? If we take negative 3, negative 3, negative 3, negative 3 4 times. 4 negative signs is a positive 81. So this answer would be plus or minus 3. Now the cubed root of negative 27. This is something we haven't seen, taking the square root of a negative number. Since we have an odd exponent, it is possible to come up with a negative answer on this. What number times itself 3 times? Well, we know the cubed root of 27 is 3, but that would have to be negative 3 times negative 3 times negative 3 to get us the 3 negatives it takes to get a negative result. So your answer for that is a negative 3. Don't try to figure out a pattern necessarily on these. There probably is one, but don't try to look at it and go, okay, in this situation I have this, would just perform each one individually. Okay? So we're going to start plugging in and solving these. Notice they have here for us this plus or minus already figured in there, because we should know that the square root of 4 is going to be plus or minus 2. So we work through this. This negative on our beginning term is not included, so I'm just going to have negative 4, 2 squared is 4, plus here the negative 3 is in parentheses, it's protected, so negative 3 times negative 3 is a positive 9, and then this is plus or minus the square root of 4 is 2. So there's two different answers here. We have to evaluate this two different ways because the square root of 4 could be positive 2 or negative 2. So we'll work across. Negative 4 plus 9 is 5, and then we're going to do the plus first. So 5 plus 2 is 7. So one of your answers is 7. And now let's do the negative with it. Negative 4 plus 9 is still 5. Minus 2 this time is 3. This is not an ordered pair. It's just two different solutions that this could be. Two different answers you could get in that situation. All right, good enough. Hopefully that makes enough sense to get you started on it. We'll take questions on it Wednesday before we grade, if you have any, to make sure that we're clear on that. Your assignment, problem set 62, 1 through 30, and again, due Wednesday. You have early morning seminar. I've only taken up about 17 minutes of your class time, so you should have enough time to get a good start on this. And that's it.